Good morning, students. When you blow air into a balloon, you will close its mouth. What will happen if you don't close it? Air comes out of it as it exerts pressure. What happens to the air in the bicycle tube when it has a puncture? Air comes out of the cycle tube. Air exerts pressure on the inner walls of their container, like a balloon or a cycle tube. Gases also exert pressure like liquids. They exert pressure on the walls of the container in which they are taken. Is air a mixture of gases? Yes, it is a mixture of gases. So, does it exert pressure? Air will exert pressure, and this is known as atmospheric pressure. Now, we will study two simple activities to show that air exerts pressure. Take a glass full of water till the brim. See that there is no air in it. And also a thick cardboard. Press the cardboard hard on the glass and keeping the card in position, try to invert the glass tumbler full of water and remove your hand. The cardboard does not fall even though the water inside the glass exerts pressure on the cardboard in the downward direction. How does this happen? It is because the atmospheric pressure acting on the cardboard in the upward direction. This upward atmospheric pressure is greater than the downward pressure of water. So, the atmospheric pressure is acting on the cardboard, which helps it to remain stuck to the glass. Now, let us see another simple activity. Take a metal can. For an empty metal can, the atmospheric pressure inside and outside will be the same. Put some water and heat the metal can with a burner. Water changes into steam and pushes the air from inside the can. When the water starts boiling, there is no air inside the can and the whole can is filled with steam. Close the metal can with its lid and stop heating. Now, pour cold water on the hot metal can. On pouring cold water, the metal can gets crushed inwards as if a large pressure is acting on it from outside. This is because when we pour cold water, the steam inside the can gets condensed to water. It changes into water and the pressure gets lowered. The low pressure inside the can and the great atmospheric pressure acting on the outside of the can are not balanced. Hence, it gets crushed inside. Consider a very long cylinder with its base having unit area. And this long cylinder with unit area is filled with air. Then the weight of the air in the cylinder is the atmospheric pressure. Let us now study a few applications of atmospheric pressure. In this image, you can see a rubber sucker. These are used to hang clothes or calendars. They are used even in toys or on the windows of cars. When the sucker is pressed against the smooth surface like a wall or a glass, the air between the cup and the wall escapes out, and this reduces the pressure inside. The outside atmospheric pressure, being more, pushes the sucker firmly to the wall. You can see a person drinking water with the help of a straw. When a person is sucking through the straw, the pressure in the straw becomes low. The atmospheric pressure outside, which is higher, will force water into the straw and consequently into the mouth. Let's see how a syringe will work. When the piston of the syringe is pulled up, the atmospheric pressure inside the cylinder will decrease. The atmospheric pressure outside pushes the liquid up into the syringe, and this is how the syringe will work. Now you might have seen a dropper for nasal drops or ear drops. The medicinal bottles, they will have a dropper. When the bulb of the dropper is pressed, the air present in the tube and the bulb escapes, and the pressure inside will decrease. The atmospheric pressure acting on the surface of the liquid pushes the liquid into the tube when we release the bulb. So here, when you're pressing the bulb, the air inside will escape and the pressure inside will decrease. The atmospheric pressure outside will be more and it pushes the liquid into the tube when you release the bulb. This is an image of a vacuum cleaner. Even vacuum cleaner works because of atmospheric pressure. When the vacuum cleaner is switched on, it sucks out the air inside the cleaner, causing the pressure to become low inside. The atmospheric pressure, which is more, forces the dust particles into the cleaner. I think you have understood the applications of atmospheric pressure. Now you can see a person having a cylinder over his head. If you consider the area of a person's head is 15 centimeters by 15 centimeters, how much weight of air would he be carrying on his head? The weight of air in a column of height of the atmosphere with area 15 centimeters by 15 centimeters is nearly equal to the weight of an object whose mass will be 225 kgs. So a weight of 225 kgs will be acting on the head. This force is equal to 2250 newtons. The reason we are not crushed under this weight is the pressure inside our bodies is also equal to the atmospheric pressure and it cancels the pressure from outside. The atmospheric pressure is maximum on the surface of the earth. When we go to higher altitudes like a mountain, the atmospheric pressure will decrease. The mountaineers suffer nose bleeding at high altitudes as the atmospheric pressure is very less than our blood pressure. Due to this, some of the blood capillaries will burst and blood comes out through the nose. Do we have air in the space? There is no atmosphere in the space. An astronaut wears a special spacesuit which maintains the normal atmospheric pressure for his body pressure to be balanced. A scientist by name Otto van Guericke invented a pump to extract air out of a vessel. He joined two hollow metallic hemispheres of 51 centimeters diameter each and pumped air out of them. He took two hollow metallic hemispheres and he pumped air out of them. Then he tried to pull the hemispheres apart. For this, he employed 8 horses on each side of the hemispheres. The atmospheric pressure is so high that they could not be pulled apart. So, in this module, we have understood what is atmospheric pressure. We have discussed various applications of atmospheric pressure, and we have also seen how great the atmospheric pressure would be.